Hey class, it's Mr. Lehman. Here's sort of a pre-lab, sort of talk about the copper cycle lab that we're going to do. So right now, Unit 6, copper cycle lab, fantastic lab. I wish you all could be here to be doing it hands-on. Typically it takes about a day and a half of class time, but here we go. This is what happens. So we're going to be doing 5 different chemical reactions. We're going to start out with some copper metal. We're going to weigh out about 0.10 grams of copper metal in a weighing dish. And then we're going to take it back to the fume hood, and we're going to react to it with nitric acid. That produces a poisonous gas. That's why we do it in the fume hood. And that's going to produce a copper compound called copper nitrate. And so what we're going to do next is we're going to react that copper nitrate, it's a blue liquid, with some sodium hydroxide. And that's going to make copper hydroxide, another copper compound. And from there, we're going to take the copper hydroxide and heat it up on a hot plate. And the heat, the energy, is going to cause that copper hydroxide to decompose, to split into 2 molecules, and one of those molecules is copper oxide. It looks like a brownish, blackish gunk. So we're going to take that copper oxide, we're going to filter it out, and we're going to add some sulfuric acid to our copper oxide solid in reaction number 4, and that is going to produce some copper sulfate, pretty blue substance, and then we're going to react the copper sulfate in reaction number 5 with some zinc metal, and that's going to produce a replacement reaction where we're going to get copper back. Alright, so we start out with copper metal, and then copper disappears. As it reacts with these different chemicals, it turns into 4 different copper compounds, and then we're going to get it back in the pure form and copper form again. So we have copper, copper disappears, and then copper comes back. And so we often call this the see you later lab. You like that? See you for copper. See you later. Alright, so if you open up the document in Canvas for the copper cycle lab, we got the materials that we're going to use today and tomorrow. So if you're doing this virtually, then you're just going to watch me do the different stations, the 5 different reactions, and this is the equipment I'm going to use. And if you're coming into class, then you're going to be doing the lab hands-on. Safety instructions, some very dangerous stuff here, right? We're working with very nasty stuff. Sulfuric acid, nitric acid, sodium hydroxide, all stuff that can cause serious eye damage, burn your skin, cause blisters. So we're going to wear safety goggles, we're going to wear lab aprons to protect ourselves from any splashes. The nitrogen dioxide gas, that brown gas you produce in the fume hood, is toxic, and so we don't want to breathe that in, even though we're just going to produce a small quantity of it. And we're going to be heating up some chemicals with a hot plate. So anytime you heat something up, you got to watch out because you can burn yourself, and then anytime you're heating up glassware, the glassware could crack. So yeah, you really got to be careful in this lab. So there's procedure, there's different steps here on page 1 and page 2 of your lab handout. I'm not going to go over these step by step. As we do the different reactions, I will point out the different parts, the different steps. And then we get to the post-lab on page 3 of your lab document. Question number 1 just says, list 3 safety concerns to the copper cycle lab. We just mentioned some of them, but as you watch the different steps, different videos, you'll see more, in more detail, I should say. This lab, one of the key concepts is the law of conservation of matter, right? So if we start out with 0.10 grams of copper metal, once we're done reacting it, we should get 0.10 grams of copper metal back, right? Because we're not creating copper atoms, we're not destroying copper atoms. All we're doing is changing what the copper's bonded with. And so, but there are some steps in this lab where we can lose some copper along the way, just from lab techniques. So as we're doing this lab, I want you to be watching me and figure out, where did Mr. Lehman leave some copper behind? Because when we're done, we should get all of our copper back, but if you weigh it, you're probably going to be down 10% or down 15% of copper, and that's sort of inevitable. Here's a good image of the cyclical nature of this lab. We're going to start out with copper powder, add nitric acid to it, we're going to add sodium hydroxide to it, we're going to heat it up, we're going to filter it, and then we're going to add sulfuric acid to it, and then in reaction 5 we're going to add zinc to it, and we'll get our copper back. In the lab handout, you see it says copper cycle lab reactions in words. So I basically wrote a sentence describing the chemicals that are involved in each step. So for instance, like reaction number 1, it says in a fume hood, solid copper metal reacts with aqueous nitric acid. There's a formula for the acid to produce. So what I start with, that goes on the left side. Those are my reactants. to produce, that is my sign that day. This is what I'm making. This is what goes on the right side. We're going to produce nitrogen dioxide gas, a blue solution of copper 2 nitrate, and water. All right. So you're going to use that information to answer post-lab questions, part 1. All right. So these blanks, all right, as you read the sentences, solid copper metal, that's the first chemical listed. So I'm going to put solid copper metal. So copper just has the formula Cu. And then because it's solid, after that, in parentheses, I'm going to put little s. All right. So that is solid copper. And that is reacting with aqueous nitric acid. So I'm reacting it. Reacting with that is represented by the plus sign. Nitric acid is my second chemical listed. So I'm going to write HNO3, and I'm doing this by hand with my mouse. That's why I'm doing actually pretty good with it. And when it says aqueous, AQ stands for aqueous. What does that mean? That means that it is a substance that's dissolved in water. So if you have a solution, if you have something that is aqueous, we're going to write AQ in parentheses after that formula. To produce is represented by the arrow. All right, and then what am I making? So that's the arrow, to produce. I'm making nitrogen dioxide gas. I'm making a solution of copper 2 nitrate, and I'm making water. All right, so those are the 3 chemicals you write here on these lines. So that's how you fill in this section. And while you're watching the lab, you want to be looking for ways that you lose copper along the way. So you want to list 3 different steps, 1, 2, 3 different places where some copper could have been left behind, where we could have lost some copper. And I'll try to point that out in the videos. And then the final step is our data table. You're going to take a screenshot or a photo of what the reactants look like, what it looks like before. So basically this is like before. That's before the reaction took place. What does it look like? You know, reaction number 1, what does it look like before? And then what does it look like after? So take a photo and put an after photo here. And then just like one or 2 sentences describing what happened. Like, you know, the color changed from blue to silver. There was bubbling. There was a gas produced. There was temperature change. These are all things I'll try to point out through words as I'm doing the reactions in front of you. But before and after photo for each reaction, and then 1 or 2 sentences describing what happened. And that is it, guys. All right, so you're going to have today, Thursday, Friday, and probably some time on Tuesday, as well as some time for review. All right, so if you have any questions, send me a message on Teams, and have a great day.